Welcome to Astro Morning Tea at ICRAR. I am Greg.
And I'm Luke.
And today we're going to talk some... Sorry, excuse me, sorry.
What is it, Greg?
What's that?
Is it the voices?
It's...
Don't listen to them, Greg.
Don't ruin the magic of
sorry,
theatre.
You're doing an act. He's doing an act. Bear with him.
What's that?
Protect yourself.
What's that? There's a breaking story involving ICRAR and neutrinos that we have to talk about immediately. I will. I'll pass on to Luke now. Luke, what's the story about neutrinos and the world and Antarctica and all sorts of cool stuff? Go.
I was impressed by that. The Oscar will be on its way. This is a breaking news story about the detection of a neutrino from an extragalactic source. This is really exciting. It's big news coming out from a large international team based out of America. Basically, there's been a long-standing problem in astronomy about cosmic rays and high-energy neutrinos coming from space, and nobody really knowing where they come from. We detected them from the sun and one particular supernovae, but no one's ever detected them coming from a particular object in space. And now for the first time, we've actually associated a neutrino detection from the IceCube experiment in the Antarctic to a blazar.
That's cool. Well, the question, of course, is why is this important? And what the heck is a blazar? So to answer that, we're going to go to Associate Professor James Miller-Jones, who was part of the discovery.
So a blazar is a supermassive black hole. So this is somewhere between 1 million and maybe 1 billion times the mass of the sun, sitting at the center of a big elliptical galaxy. Now, the special thing about a blazar is that it produces what we call relativistic jets. So these are oppositely directed beams of particles coming out from very close to the black hole, launched by the energy that comes from material falling in towards the black hole. And these jets carry away very energetic particles and produce a lot of radiation. The key thing about a blazar is that it is beamed right at us. So it's pointing, the jets are pointing right towards us. We're looking down the barrel of these jets. And that means that the radiation that we see from them is much more intense than we would see from any normal jet from a more typical black hole. So we're able to see things that would normally be a little bit fainter. So why was this important? It gives us a new window into how these blazars actually work. So neutrinos don't interact very well, so they allow us to see right down to the very core of the black hole engine. It shows us exactly how particles are accelerated to very high energies. And what it tells us is that those particles are protons, which are positively charged, instead of electrons, which are negatively charged. And that tells us a lot about the amount of energy these jets can carry away. So this new window on the universe is telling us about the inner workings of some of the most powerful engines that we have. Some of the most powerful sources of feedback of energy and matter to the cosmos.
Thank you, James, for putting that into context. It's actually a really exciting discovery.
It is, yes.
It's actually one of those big things, kind of like the level of gravitational waves, or really? I mean,
Yeah, so it's a real kind of push towards this idea of multi-messenger astronomy, which is astronomers all around the world all collaborating, that's what I'm looking for, together to form an amazing detection. So basically, once the neutrino was detected, all of these telescopes all around the world all pointed at the same direction to try and find out where it was coming from. So we have lots of observations of this particular blazar at lots of different wavelengths, and it's this huge coordinated effort for astronomers all around the world. And we're now moving into this regime where astronomers are all working together in a global sense, which is pretty amazing.
I love it. I love the fact that all these instruments and all these institutes are working together to find things about the universe we've never known before. Get some real answers. Exciting stuff.
Real answers.
Real
That's
answers.
Rubbish that we've done before.
Relativity, it's all out of the way now. Thank you, Luke.
Thank you, Greg.
And thank you, listeners and watchers, if you're doing both. And readers, we also have it in captions. Very important. We'll see you next time.